Hi, the goal of this video today is to teach you how to determine what an empirical formula is if you're given the percent of each element in a compound. And I have created a document called Empirical and Molecular Formula Tutorial. And today this video is going to focus on how to determine the empirical formula of a substance. So I didn't need to cross off tutorial because this is a video tutorial of how to use this method that I'm going to have you use. So the empirical formula of a substance is the lowest whole number ratio. And for example, there is the element glucose. And I have, let's just scroll down a little bit, we'll look at this. So I have the element glucose, and glucose has a formula of C6H12O6. Now that is its molecular formula. That tells us how many actual atoms there are of each element in that molecule. So here is a molecule of glucose, and you will count 6 carbons, 12 hydrogens, and 6 oxygens. Now, an empirical formula is the lowest whole number ratio of a compound. Now, since these numbers are all divisible by 6, the empirical formula for this is going to be CH2O. So our goal is to use percent composition of each element in a compound to get to this value. So let me just go back up to the top of this tutorial and remove my face from that. There is a poem that we use, and the poem goes like this. I want to get into my poetry mode, so percent to mass, mass to moles, divide by small, multiply till whole. There, that's the poem. Now let me show you how to use this. Here is the question that you'll get answered. So you will get asked. So you will get asked a question, what is the empirical formula of a substance if you are given its percent of each element? So here's an example. A compound consists of 72.2% magnesium and 28.7% nitrogen by mass. What is the empirical formula? The percent to mass part of the poem has us assume 100 grams of the substance. Now, if we have 100 grams of the substance and there are 72.2% magnesium, there is 72.2% magnesium, then there will be 72.2 grams of magnesium. And since nitrogen is 27.8%, we'll have 27.8 grams. So the first step is to write the numbers down that's given and the formula, and we change percent to grams. So the next part of the poem is mass to moles. So now what we need to do is use the roadmap to calculate mass to moles. Now on the roadmap, the mass value was down in this corner, and the moles was up here, and then we had liters up here, and we had particles down here. So we had mass, we have moles in the center. To go from mass to moles, the conversion factor is 1 mole over the molar mass. So what I'm doing here is I am using that conversion factor. So the molar mass of magnesium is 24.3, and when I do the math in the calculator, 72.2 divided by 24.3 equals 2.971 moles of magnesium. Now, some of you are actually writing down the calculation for this. You do not need to include that step. If you have this and you show me an answer I'm implying. It's implying that you are looking at this and saying, okay, I'm starting with 72.2 times 1 divided by 24.3 equals this. You don't have to rewrite the mathematical calculation. So that does not need to be part of your work. Just what I've shown is all you need to do. The molar mass for nitrogen is 14.01, so 27.8 divided by 14.01 is 1.984. Now, I underlined this for a reason. If we go back up to the poem, in the poem, I have the word small underlined. And I love color coding and symbolic things. I think that it helps with learning. So when we get an answer to step 2, we have to look at which of the answers is the smallest. And what I did here is I underlined it. 1.984 is the smallest answer. So the next step, first of all, let me focus on this. At step 2, you're using the mass to moles portion of the roadmap. And I'm giving you the values of molar masses from the periodic table. And also at this step, I want you to round to 3 places past the decimal point, as I did here. It's really important to do this to get the best results. So the next step is divide by small. So here I have taken, I've written down everything up until the green, and I'm taking that 1.984 and I'm dividing each of the sides by that small number, and the value that I get for magnesium is 1.497, which is very close to 1.5, and then one of them is always going to be 1, because if we're dividing by the smallest amount, that one will always be divided by itself, and it will always be 1. Now, when you look at the answer here, you notice that this is not a whole number, and it's not close to a whole number. In fact, it's about half of a whole number, 0.5. So the next step, if we go back up to the poem, percent to mass, mass to moles, divide by small, which is what we just did. Now, if the numbers are not whole, we have to multiply till whole. So we need to, it says, since at least one blue answer isn't close to a whole number, we have to multiply it by a number that'll make it whole. But whatever we do, we have to do it to all of the numbers. Since this is a 1.5, if something ends in a 0.5, we would multiply everything by 2 to make it whole. If it ended in 0.33 or a 0.66 or something close to that, sometimes you see 0.32, sometimes you'll see 0.34, sometimes you'll see 0.67. So if it's close to either one of those numbers, then you would multiply everything by 3 to make it whole. And if it's around 0.25, you'll multiply everything by 4. So the thing we have to remember is if we double or triple or quadruple anything at this step, we have to do it to all of them. So since it ends in 0.5, I multiplied till whole. And what we see here is the final solution. Now, if you are doing this, you don't need to rewrite this every single time. I was just doing this in steps. So for the question, what is the empirical formula for a compound that is made of 72.2% magnesium and 27.8% nitrogen? This is the full solution for how to get the empirical formula. So let's just go through the steps. Percent to mass, we assumed 100 grams, which made us put that number, the same number with the grams unit after it. Mass to moles, we converted to moles using the mole conversion from our road map, our mole roadmap. And then we get an answer here. And the next step was divide by small. Whatever number this is, we divide each of them by that. And then if these are already whole numbers, you don't have to go any farther. But if they're not, then we multiply by a multiplier that will make it whole. So again, this is ending in 0.5-ish. So if we double it, it ends up being in the calculator 2.995. And that is so close to 3. So with this one, we also double it. We get 2 for that. So the formula is Mg3N2. Now what you see in this box is the acceptable work that you would want to show for completing a problem like this. It is very important that you show units and formulas at every single step. So this is the model problem for what your problem should look like. All right, we're going to very quickly go through another one. So this is just a problem that's going to set us up for solving molecular formula. But since my focus is empirical formula today, we're going to do that part of it today in this video. All right, so we have a compound that is 68.54% carbon, 8.63% hydrogen, 22.83% oxygen. So that first step is assuming that we have grams. So the first thing we're going to write down is the grams of each thing, including the G and the element formula. Mass to moles, we have to use the appropriate conversion factor. And these are the conversion factors for carbon and hydrogen and oxygen. Now, the good news is I'm going to give you quite a few of the practice problems you're going to do are going to involve carbon and hydrogen and oxygen. So you'll be able to memorize these numbers pretty quickly. Again, at this step, we want to report all of our answers to 3 digits past the decimal point. Divide by small and multiply till whole. Okay, so here I have, it seems to be just cut off a little bit. Maybe not, I don't know. Yeah. I guess it's cut off a little bit. All right, so I have the poem up here, percent to mass, mass to moles, divide by small. And what we're going to discover here is that when we get to this point, the numbers round to whole numbers, so we don't need to round by anything to get it whole. So the first step, write down the number for each percentage in grams. The second step, convert to moles. So for carbon, you will divide by 12.01. For hydrogen, you divide by 1.01. And for oxygen, you would take that 22.83 divided by 16. What I've done here is I have circled the smallest number. I think it would be a good idea for you to get into that same habit. We can use some of the same symbols and tricks as we guide our way through this. I divided each of those numbers by small, and for the carbon I got 3.999, which is very close to 4, and for hydrogen 5.989, very close to 6, and then for oxygen it's 1 and it's 1. So the formula for this is C4H6O1, but we don't write the 1. So in this video, I have modeled how to solve problems to determine the empirical formula of a substance. And in the next assignment, I'm going to teach you how to get the molecular formula of a substance, and you'll be able to practice a little bit with that too. So thanks for watching.